Okay, now I'm just going to go over some other quartic graphs and equations and examples to get you used to what they look like and how to sketch them. Let's do y is equal to 1 plus x squared, 1 minus x squared. So the roots, both of them are going to be repeated, and the power of 2 repeated. Both of them are therefore repeated roots. They're going to be minus 1 and 1. The y-intercept is going to be 1. And it's going to be a positive graph because remember the 2's up here, so there's 2 brackets, so it's minus 1 times minus 1 times 1 times 1, which is going to be positive 1, so it's going to be a positive graph in the W shape that we're familiar with. So if we sketch it, remembering the repeated roots, it's going to look something like this. Remembering to label, so this is going to be minus 1, this is going to be 1, and this is going to be 1. Now let's do y is equal to x squared plus 5x plus 6 and x squared plus x plus 1. Well, we can factorise the first bracket here to get x plus 3, x plus 2, but we can't factorise the second bracket. You'll find you can do the discriminant if you want, or just put it into a calculator, but you'll find that there is no roots, so we have to keep it like that. So this is the completely factorised form that allows us to sketch the graph. So the roots are going to be at minus 3 and minus 2. The y-intercept is going to be 6, and it's going to be a positive graph in the kind of the W shape. So if we sketch this, it's going to look something like this here. Remember to label, so this is going to be minus 3, this is going to be minus 2, this is going to be 6, and this here, there's going to be a turning point here because of the last bracket here, so just remember that. Quickly, let's just do y is equal to x plus 1 to the power of 4. So the root is going to be at minus 1, the y-intercept is going to be 1, and it's going to be a positive graph. Now, when it's a repeated root to the power of 4, just note that it's going to look like to the power of 2. So the power of 2 and the power of 4 repeated root look the exact same. So if we sketch this, it's going to look something like this here. Remember to label, this is going to be minus 1 and this is going to be 1, and we're not going to have any other turning points because when we have for a quartic or repeated root to the power of 4, there's no other turning points, there's no other brackets kind of like here that kind of make a turning point. All of it is kind of, I guess you could say, absorbed by the repeated root, and we don't need to draw another turning point. So we've seen quartics that have 4, 3, 2 or 1 roots, but a quartic could also have 0 roots. For example, this is with y is equal to x to the power of 4 plus x to the power of 3 plus x squared plus x plus 1. If you put this into a calculator, you'll find that it has 0 roots and you cannot factorise this any further. So if you sketch this, this is going to be the y-intercept plus 1, and it's going to be a positive graph sort of in the W shape. So if you sketch this, it's going to look something like this here, something like this in the kind of W shape like this, where this is going to be 1. Now the reason a quartic can have 0 roots but a cubic can't is because of kind of how their shape looks. This is a positive quartic and this is a positive cubic. You find that these kind of two tail looking things on the end for a quartic end up on the same side to the point where you could have it as shown on the left in the graph, where it doesn't go through the x-axis. But with a cubic, because they end up on different sides, these kind of like tails, what you'll find is that when you sketch it, it has to go through the x-axis at some point, otherwise a cubic can't exist. So here's a couple of questions on cubic and quartic graphs, so pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for the first question, the roots are going to be 0, 1, and minus 2, the minus 2 being a repeated root to the power of 2. So if we do this, we'll put 0 about here, we'll put 1 about here, and minus 2 about here. the minus 2 being the repeated root. The y-intercept is going to be 0, because remember we treat this as x plus 0, so we times by 0, and it's going to be a negative graph, because if we times all the coefficients of x together, we're going to get negative 2. So it's going to be a negative graph that looks like this sort of M shape. So remember, when we have a repeated root at the minus 2 root, we're going to draw it looking something like this here. Remember to label, it's the most important thing. So this is going to be minus 2, this is going to be 0, and this is going to be 1. So for the second question, the way we answer this question is by looking at the where it intersects the coordinate axis, because it tells us that, and more specifically what the roots are. So as we know the roots, we can write the equation in the factored form. As we know the roots are minus 4, 1 and 4, we can write it as x plus 4, x minus 1, x minus 4. And then we can expand it in order to get it into the form of the equation that it wants here. So if we expand this, let's expand x plus 4 and x minus 1 first. So we're going to get x squared plus 3x, because if we expand it longhand, it'll be plus 4x minus x, so plus 3x minus 4, and the other bracket is x minus 4, and then we times these two brackets together to get x cubed plus 3x squared minus 4x minus 4x squared minus 12x plus 16, which we can simplify to get x cubed plus minus x squared minus 16x plus 16. Now, this could be the final answer, however, there's one other thing we need to consider, and whether, because of the way it will work, is it could technically, instead of being the factored form that we said here, one of the brackets could be a 2x instead, and it could be something like 2x plus 8, x minus 1, x minus 4, for example. That is a possibility, and this will give the same root. This will also give the minus 4 root. So we do slightly need to consider this. So the way we would consider this is we would do that y is equal to a x cubed minus x squared minus 16x plus 16. And then we need to see what the value of a is, whether any of the brackets would be in this form where they're times by 2. Well, the way we can actually check this is, remember that the last number is going to be the y-intercept, and therefore as the number that we've got here is the same as the y-intercept, we know that a is just going to be 1, aka that a doesn't exist, so therefore it's just going to be y is equal to x cubed minus x squared minus 16x plus 16 as the final answer. So therefore you can say that a is equal to 1, b is equal to minus 1, c is equal to minus 16, and d is equal to 16. So just check that, just in case. Make sure that the final digit here is matched up with the y-intercept as well, so therefore you definitely know that you've got the right answer. Another way you can check to make sure that you've expanded the brackets properly for this bit over here and for your answer here is you can put your expanded equation into the calculator and use it and solve the equation using the polynomial degree 3, and if you get out the same roots, minus 4, 1 and 4, you know that you've expanded it correctly, and therefore that's a good way of checking that you've got the final answer right.